Good day everyone, welcome to another video, and today we will try to rederive the following formula. Suppose we have a triangle with side lengths A, B, and C, then according to Heron's formula, the area of this triangle is equal to the square root of S multiplied by quantity S minus A closed, multiplied by quantity S minus B closed, multiplied by quantity S minus C closed, where S is known as the semi-perimeter is equal to A plus B plus C all over 2, in which semi-perimeter is just basically the half of the triangle's perimeter. Now, what is so special about Heron's formula? Well, if we want to solve for the area of a triangle, usually we use this formula, right? Which is A is equals to base times height over 2, right? Well, what if we don't know what is h? Or in other words, what if we don't know what's the height of a triangle? But it is given that the side lengths of all of its edges are given, which in this case A, B, and C, then can we still then solve for the area? Well, there must be some way to solve for the height of a triangle, right? Maybe through the use of trigonometry, or perhaps by doing some geometric slash algebraic manipulation in order for us to solve for the h and ultimately solve for the area of a triangle. But surely there must be some way or some formula that we can conveniently use in which we just have to plug in all of the side lengths of a triangle and then we'll just solve for the area of a triangle directly. Well, that's the magic of the Heron's formula, right? We can solve the area of a triangle directly by just knowing the side lengths of a triangle, which in this case it's A, B, and C. Just plug it in and then we'll get the area of a triangle. Now, with that, let us try to derive Heron's formula. Now, suppose we have a triangle, right? Let's just draw another triangle with the side lengths A, B, and C. Okay. Now, what I would do is I would let the height of this triangle, so this is its height, and let it be equal to h, right? Now, by using our usual formula for a triangle, it is just A is equal to C times height over 2, correct? Now, what we would do to solve for, or rather rederive Heron's formula, is we want to eliminate this variable h, which is the height. And we want to rewrite the area of the triangle in terms of A, B, and C, right? So how will we do this? Well, notice here in our triangle that when we write down the height of this triangle, we divided this triangle into two smaller triangles, right? Of course, they're not equal to each other, but we divided them into two triangles, right? And the base of this triangle, let's say it is equal to x, okay? Let's just say, all right? And then, if this part is equal to x, then this second part is equal to c minus x. Now, why does it equal to c minus x? Well, notice if we add these two bases, x plus c minus x, the two x's will just cancel out, giving us c, which is the base of our bigger triangle, correct? Now, what I would do is I would apply Pythagorean theorem in this first triangle, okay? So by Pythagorean theorem, we can see that x squared plus h squared is equal to a squared, right? Now let us denote this as our equation 1. And let us set it aside for a minute, okay? Now, next, we try to look at the second triangle. Now again, by using the Pythagorean theorem, we can see that the square of c minus x plus h squared is equal to b squared, right? And then, by turning this a perfect square trinomial, we can see that c squared minus 2cx, right, plus x squared plus h squared is equal to b squared. And let us denote this as equation 2. Now what we would do is subtract equation 2 from equation 1. So equation 1 minus equation 2. Okay? And then we can see that this would be x squared plus h squared is equals to a squared minus equation 2. So what we would do is multiply negative in both sides, or rather negative 1. So this will become negative c squared plus 2cx minus x squared minus h squared is equal to negative b squared, correct? Now, evaluating this, we can see that the x squared will cancel out, the h squared will cancel out, and then this would leave us with negative c squared plus 2cx is equal to a squared minus b squared. And next, what we would do is add both sides by c squared, giving us 2cx equals to a squared minus b squared plus c squared, right? And then, dividing both sides by 2c, we could see that x is equals to a squared minus b squared plus c squared all over 2c. Okay? And then, let us denote this as our equation 3. Now, what we would do is substitute, right? We would substitute equation 3 to equation 1, right? So, this would give us x squared plus h squared equals a squared. Then, substituting the equation 3, or the value of the x that is derived, then we could see that this will become the square of a squared minus b squared plus c squared all over 2c, right? Plus h squared is equals to a squared. Okay. The next, we would subtract both sides by this expression. So this would give us h squared being equal to a squared minus the square of a squared minus b squared plus c squared all over 2c, right? And then taking the square root of both sides, and then we would find that the height of this triangle is equal to the square root of a squared minus the square of a squared minus b squared plus c squared all over 2c. That's good. And then, by this, we can now then substitute the derived formula for h into the area of our triangle, in which we could now then eliminate the variable h in our formula for the area of this triangle, right? So we would find that area of this triangle is equal to ch over 2. Substituting this formula for h, we would find that the area is equal to C times the square root of A squared minus the square of A squared minus B squared plus C squared, right? All over the square of 2C, right, which is 4C squared. Okay, that's 4C squared. It's really small. All over 2, right? So what I did here, I just basically distributed the square in the numerator and denominator, okay? In case you're wondering. And then next, we would rewrite this as A is equal to C over 2 times the square root of, oops, it's too small. The square root of A squared minus the square of A squared minus B squared plus C squared, all squared, all over 4C squared. And then next, what we're gonna do is we can rewrite C over 2 as the square of C squared over 4, correct? Since if you take the square root of that, it'll just be C over 2. Let's make this bigger. And then again, multiply by the square root of A squared minus the square of A squared minus B squared plus C squared, all over 4C squared. Then, since both of them are raised to the same exponent, which is 1/2, right? That's the square root. Then we can rewrite this as A equals to the square root of C squared over 4 multiplied like this, right? Multiplied by A squared minus the square of A squared minus B squared plus C squared, all over 4C squared. Good. Let's make that longer. Now, next, what we would do is distribute C squared over 4, right? So what would happen? We would see that the area of the triangle is equal to the square root of, this will become A squared, C squared over 4, correct? Minus. Now, if you would notice, there's a C squared present, right, in the denominator. So that would cancel out. And then this would just leave us with the denominator 4, right? And then 4 times 4 is just 16. So this would leave us with the square of A squared minus B squared plus C squared, all over, again, 4 times 4 is 16. Okay? There you go. Then next, by evaluating this fraction, this difference of fractions, we could see that the area of the triangle is equal to 16A squared C squared minus 4 times that, it will be 4 multiplied by A squared minus B squared plus C squared, all squared, right? All over 4 times 16, that is 64, correct? Okay. Just make this bigger. Now notice that we can factor out 4 from the numerator, right? So we can rewrite this as A equal to the square root of 4 multiplied by quantity 4A squared C squared minus the square of A squared minus B squared plus C squared, right? We can do that. And this is all over 64. Okay, now 4 over 64, that's the same thing as 1 over 16. right? So a is equal to the square root of 4a squared c squared minus the square of a squared minus b squared plus c squared all over 16. Good. And then notice that this is a difference of squares, right? So 4a squared c squared is the same thing as the square of 2ac, correct? So let's do that. This will become a equal to the square root of quantity 2ac. Is that correct? Yeah, that's correct. Minus the quantity of a squared minus b squared plus c squared multiplied by quantity 2ac plus, right? So in this case, we would drop the parentheses, a squared minus b squared plus c squared all over 16. Let's make the square root bigger. Let's see. Okay, that's correct. All right. And then in here, we would distribute the negative. So we can see that a is equal to the square root of quantity 2ac minus a squared plus b squared minus c squared multiplied by quantity 2ac plus a squared minus b squared plus c squared, right? All over 16. Good. And then what we would do is factor out negative from this expression, giving us a being equal to the square root of negative uh, negative 2ac plus a squared minus b squared plus c squared. Goods. Multiply by quantity 2ac plus a squared minus b squared plus c squared all over 16. Okay. And then next, rearrange the following. A is equal to the square root of negative. Alright, so this we would write this as a squared minus 2ac, right? Plus c squared, yeah, minus b squared. Multiply by quantity a squared plus 2ac plus c squared minus b squared all over 16. Good. Then notice we have a perfect square trinomial here, right? So let's do that. This will become a equal to the square root of negative quantity, then another quantity of a minus c all squared. Is that correct? A squared minus 2ac plus c squared. Correct. Minus b squared close. And this is also the same thing. You can rewrite this as quantity a plus c whole squared minus b squared close all over 16. Okay. So let me change my paper real quick since I'm running out of space here. This will become a is equal to the square roots. Okay, I would distribute the negative here. Okay, I would distribute the negative. Just do this real quick. There you go. Okay, this will become quantity b squared minus the square of a minus c closed multiplied by quantity the square of a plus c closed, minus b squared closed. And this is all divided by 16. Good. And then notice again, we have a difference of squares here. All right? Let's remove that real quick. We have a difference of squares. So let's use the formula for that. We can rewrite this as a is equals to the square root of this. We could rewrite this as quantity b minus quantity a minus c closed again, correct, multiplied by quantity b plus, right, plus a minus c. Good. And then this also a difference of squares. So this is quantity a plus c, right, minus b multiplied by quantity a plus c plus b. All right, let's make this longer. All over 16. Okay. So we're getting close there. I can already see it now. What I would do is distribute the negatives here. So this will become a is equals to the square root of, distribute the negative, okay? This will become b minus a plus c, correct? And this will become, let's apply commutativity here. So this will become a plus b minus c, correct? This will become as is a plus c minus b. We just drop the parentheses inside. Multiply by quantity a plus, let's switch the b and c. So this will become b plus c all over 16. Now notice all of this expression can be rewrite as follows. So a is equals to the square root of, so this will become a plus b plus c, right, minus 2a, correct? Since if we evaluate that, we would return to our original expression, multiplied by quantity a plus b plus c minus 2c, right? Again, same thing. Okay, multiply by quantity a plus b plus c minus 2b. Okay, same logic, right? Let's make this longer. Multiply by, okay, as is a plus b plus c all over 16. Then, next, we know that 16 is 2 raised to 4, right? 16 is 2 raised to 4. So, we can separate this into 4 separate fractions. So, we can rewrite a as the square root of, let me see, okay, a plus b plus c minus 2a all over 2 multiplied by a plus b plus c minus 2c all over 2 multiplied by a plus b plus c minus 2b all over 2 multiplied by a plus b plus c all over 2. Okay, good. And then we can rewrite this as a equals to the square root of, this would be the same thing as, all right, let's rewrite it in parentheses. So this will become a plus b plus c over 2, right, minus 2a over 2, but 2a over 2 is just a, right? So this becomes minus a multiplied by quantity a plus b plus c all over 2 minus 2c over 2, but 2c over 2 is also c. So this is c. And then a plus b plus c all over 2 minus, same logic, this is b. And then as is a plus b plus c all over 2. Okay. And then I think you can see it now that a plus b plus c over 2 is equal to s. Here, as you can see, right? S is equal to a plus b plus c all over 2, correct? So, what we would do is substitute the value of S, right, in our derived formula for the area of the triangle. And then, this would give us the area of the triangle. A is equal to the square root of S minus A, multiplied by quantity S minus C, closed, multiplied by quantity S minus B, closed, and then multiply by S simply. Good. And then just apply some commutativity. Rearrange this as square root of S multiplied by quantity S minus A multiplied by quantity S minus B multiplied by quantity S minus C. Finally, we've expressed the area of a triangle in terms of its side lengths and its semi-perimeter, and hence rederiving the Heron's formula. And with that, we are now done.